Very good morning to all of you. So, is the audio video is clear to everybody? First of all, you tell me. Audio video is clear to everybody. Welcome you all. Welcome you guys. Right. So, actually, we have to complete the syllabus within 1 week. This week, by this Saturday, we need to finish the syllabus, and next we need to start the next topic. We have to start revision. हम शुरू करना पड़ेगा. इसीलिए so we have to take the online classes. All of you try to cooperate with me so that everybody listen carefully, try to understand each and every topic what we are going to discuss. And don't worry, I don't take much time. I will take hardly 1 hour or 1.5 hours. I will take more than that. I won't take. I don't disturb you also. Fine. So here, yeah. So I will use English only. Don't worry. So कभी कभी टाइम मेरा मैं ये हिंदी में चला जाएगा. So don't worry. So then I will use English only. So right. Chalo, let's start our discussion now here, everybody. So here, and this is the new chapter we are going to start. It is a nuclei. The new chapter we are going to start. It is what? Tell me, nuclei. And what the nucleus means? What? Tell me. Nucleus. Nucleus means it consists of neutrons and the protons. And previously we have discussed of the electrons. Now we are going to talk about the previously we have the atoms. Atom consists of what? Tell me. Electrons, protons, neutrons. And the electrons will revolve around the nucleus. And the protons and neutrons together will be called it as a nucleons. The protons and neutrons are called as what? Nucleons. Now, so nucleus will lies at the center of the atoms. Nucleus will lie where, you tell me? At the center of the atoms. At the nucleus, so maximum mass, almost 99% of the mass and the complete positive charge will be concentrated at the nucleus only. At the center, entire mass and the complete positive charge will concentrate it. And neutrons and protons together are called as a nucleons. And so as we know here, what is atomic number? That the number of protons is called as an atomic number, which will denote with a letter of Z. The number of protons present in the nucleus is called as what? Tell me. Atomic number Z. And the total number of protons and neutrons, the number of protons and neutrons, which we used to call it as what? Tell me. Atomic mass number. Atomic mass number. If I call A is atomic mass number A, which is given as what? Tell me now. Number of protons. Number of protons will denote it as what? Tell me. We can indicate it as a Z plus number of neutrons. N is the number of neutrons and A is the atomic mass number and Z is the atomic number. So from this we can get the number of neutrons. How many neutrons are there, you tell me? Neutrons, N is equal to what? Tell me. A minus Z. N is equal to what? A minus Z. Right. Chalo. Copy this thing. Copy it, all of you. And tomorrow class, I'll check all your class notes. Everybody has to be there. Everybody must be complete all the topics what we have covered. In your class notes, you need to complete it. Keep in mind. Tomorrow, I'll check all your class notes. There should not be any incompletion of the class notes, remember. Copied all of you? Yes, we have college tomorrow. Completed. Whether you write or now or not, so it doesn't matter. But thing is, tomorrow I'll check your class notes. In our class notes, what are the topics we have completed, those topics must be present. Hmm. So jaldi copy karo fast. Do copy it. So do copy it fast, everybody. Chalo. Now, so let's see what are the different type of nucleus we have. Different type of nucleus. You might be studied about the different type of nucleus. So in your chemistry also you might be studied about this different type of nucleus. That is, one is called as isotope, and this one. So here there is other one. So which is called as a iso isotones. Okay, so this is one is called as a isotope, the other one is isotones, isobar, and isomers. So hope you might be heard about these words: isotopes, isotones, isobars, and isomers. What is this isotopes means what? So the atomic nuclei having same atomic number but different mass numbers. Same atomic number but different mass numbers are called as isotopes. Same atomic number. I hope all of you might be know this thing here. So we have some any atom hydrogen. So where this one here will indicate it as what, tell me, atomic number. Here we indicate it as what, tell me, mass number, isn't it? So this is our atomic number and this is the mass number. So look at now here in this case. This hydrogen we have different type of isotopes are there. So you can see now here atomic numbers are same and mass numbers are different. Na? Atomic numbers are same but mass numbers are different. So these are called as what, tell me? So these are called as a Isotopes. Next. And isotones. What the isotone means? What, tell me? Having same number of neutrons. Having same number of neutrons, different atomic numbers. Same number of neutrons but different atomic numbers. And mass numbers. These are called as what, tell me? Isotones. So same atom number of neutrons, how we can calculate now here, which is nothing but A minus Z. Now number of neutrons equal to A minus Z. A is the atomic mass number, Z is atomic number. So the difference between them must be same. So in this case, you can tell me now here, 17 minus 8, how many neutrons are there in the nitrogen? How many neutrons are there? You can see now here, 10. How many neutrons are there? 17 minus 7. How many are there? 10. So 18 minus 8. How many are there? You tell me. 10. So 19 minus 9. So how many are there? 10. In all the cases, how many neutrons are there? You tell me. 10 neutrons are there now. 10 neutrons are there. So this type of nuclei is called as what? This type of nuclei is called as isotones. Right? So isotope means same number of atomic number. That means same number of protons. Same number of protons. Isotones means same number of neutrons. Isobar. And what the isobar means? Tell me. What about this isobar means? What? Having same mass number. Having same mass number. And with different atomic numbers are called as isobars. This thing will helpful for both IP as well as object दोनों के लिए, for both purpose this thing. Now, so isobar means what? Tell me. Having same mass number. You can see mass number for this argon and calcium both are same only. Now you can see 40 40. Mass numbers are same and atomic numbers is what? Tell me now. 18. Here it is at 20. So it has a different mass numbers and different neutrons, but it has the same number of mass number. Same number of mass number. These are called as what? Tell me. Isobars. And isomer. Isomer means what? Tell me. So same atomic number, same mass number, but with different energy levels. Okay. Yeah, you can copy it. Same atomic number and same mass number. Same atomic number and same mass number, but with different energy levels. Different energy levels are called as isomers. Isomers, you might be heard about this thing here. So these are the two examples. N-butane, isobutane are called as isomers now. Have you heard these words? N-butane, isobutane. The structures are different. So that means the energy levels are different. Energy levels are different, but so here atomic number and mass number both is same only. These are called as what? Tell me. Yes, this large side is not visible now here. After that width, you can write it as after the width here. Different energy. So this corner is not visible now after width. So that is different energy. Mm. Copied all of you? Right. Next one. Now let us see some of the properties of nucleus. Some of the properties of nucleus. See this thing, first property. One by one properties we'll discuss. The first property is, what you have not yet copied. Do it fast. Right. And first of all of you do like the session. Hmm? Everybody do like the session. Then, sure. Next one, properties of nucleus. Let's see the first property. First property is, and what is the shape of the nucleus? What is the shape of the nucleus? Shape of nucleus is what, tell me? Is what? Spherical. Shape of the nucleus is what? Spherical. So here, ideally speaking, it is not perfect sphere, but we should consider the shape is almost a spherical shape. So 95% is a perfect sphere, only 5% is a little deviation is there. But we should consider the shape of the nucleus is a perfect spherical, we should consider. Shape of the nucleus is a spherical. Circle is a two-dimensional. Circle is a two-dimensional. But here the atom, the nucleus is three-dimensional. That's why it is called as a spherical. Okay. Next, charge of nucleus. Charge of nucleus, which is given as what, tell me? Z into E. Charge of nucleus. Z is equal to what? Q is equal to what, tell me? Z into E. Where Z is an atomic number, E is an electron charge. Z is an atomic number and E is an electron charge. Right. Next one. volume of nucleus is directly proportional to the mass number. Directly proportional to what? Mass number. Mass number is what? A. Volume of nucleus is directly proportional to the mass number. So that is volume, which is directly proportional to mass number. Volume of the nucleus is directly proportional to what? Mass number, like this. And volume. So tell me, what is a volume we can say here? Volume, which we can say volume is sphere na 4 by 3 pi r cube, which is proportional to what? Mass number is A. Now this whole term 4 by 3 pi is a constant. When I bring to other side, so simply can I write it as a r cube proportional to A. That part 4 by 3 pi is a constant now. So I can write it as what? Tell me now here, r proportional to A power 1 by 3. So what I can say now, r proportional to A power 1 by 3. So where this r, which is given us, we can write it as a r naught into A power 1 by 3. R is equal to r naught into A power 1 by 3. So from this r, which is given as, where this r naught equal to, so where this r naught, which is equal to what? Tell me, this value 1.2 into 10 power minus 15 meters. R naught is given as 1.2 into 10 power minus 15 meters. This can be written as what? You tell me, 1.2 Fermi. 1.2 Fermi. Fermi means what? Tell me, 1 Fermi, which is equal to 10 power minus 15 meters. Right. R proportional to what? Tell me, A power 1 by 3. So that means, which I can write from this, R1 by R2, which is equal to what? Tell me, A1 by A2 power 1 by 3. R1 by R2 equal to A1 by A2 power 1 by 3. Okay. Volume of the nucleus is directly proportional to the mass number. Yes, copied all of you. Yeah, copy karo. Yes, do copy it. Why? Is a video is trucking. R is a volume na. Radius. What is the radius of the sphere? 4 by 3 pi r cube na. That's why. R is what? Radius. What is the volume of a sphere is a 4 by 3 pi r cube. Hmm? You're talking about R naught. You want to say this R naught value, where this R naught will, when I bring this term, it is this side will come, the constant will come now. That constant value, it will be this much. The constant value, if we calculate the substitute the values, simplify, then will come to be this much, 1.2 into 10 power minus 15 meters. Yes. Next one, density. Density of the nucleus. Density of the nucleus. And basically density, which is given as what? Density given as mass by volume. Density given as what? Mass by volume. So tell me the mass here, we are finding the density of a nucleus means mass of the nucleus by volume of the nucleus. Mass. So here mass, which will be, which we can write it as what, tell me now here? Mass number into the mass of one particle. Mass of one particle. Inside we have a nucleus. What are the elements are there? Both protons and neutrons are there. So sum of protons and neutrons is called as what will be mass number A now. So that means mass of one particle multiplied with the mass number will give the total mass of a nucleus will come. So from this density D, which is given as what I can say, A is a mass number into mass by volume is given as what? 4 by 3 pi r cube. Okay. Now tell me now here from this D is equal to A into M into 4 by 3 pi r cube, where r, just now we have seen r is r proportional to r is equal to r naught into a power 1 by 3 we have seen now. We'll substitute this thing, r equal to r naught into a power r naught into a power 1 by 3. For the whole power we have a cube is there. So simplify this thing, will come it as what, tell me now? A m by 4 by 3 pi into r naught cube into what, tell me now? A cube. So this will get power and 1 by 3 will get cancelled. Now here this A will get cancelled. So then you can see now here how much the D value will come to be a. D value will come to be a what, tell me? So this is 3 will come to numerator m by what I can say now here, 4 pi into r naught cube. Now so this is, you can see now here, which is independent of the atomic mass number. So with m, so this, if I substitute the values of this thing, we can simplify, then we can get the value of D. Density, it should be come to be a nearly 2.3 into 10 power 17 kg per meter cube. It will come to be a this much. So D is equal to what, tell me? 3m by 4 pi r naught cube. That value come to be a 2.3 into 10 power 17 kg per meter cube. This is the density we got, and you can see now this density which is independent of atomic mass number. Is it fine? Right. Completed? Right. Next one. Nuclear forces. Take the next one. Nuclear forces. Nuclear forces. Nuclear force means this is the attractive force between the nucleons. Nucleons means what? Tell me. Nucleus and the protons. That forces are called as a nuclear forces. The attractive force which holds the nucleons together is called as a nuclear forces. And so the forces between the nucleus and the proton, neutrons and the proton, that force is called as a nuclear forces. Nuclear forces are very, very strong forces. Nuclear forces are very, very strong forces. Compared to all the forces, nuclear forces are very strong. Now, here this is Fg is a gravitational force. Fg is a gravitational force. Fe is the Coulomb's force. Fe is a Coulomb's force. And Fn is a nuclear force. Is a nuclear force. Then, so this ratio, it should be given as what? Tell me. 1 is to 10 power 36 into 10 power 38. Compared to all the forces, nuclear forces are very strong forces. Okay. And but nuclear forces are very short range forces only. So this can exist very short distance only, they can exist. Nuclear forces are short range forces. These are what I mean, short range forces only. And these nuclear forces are strong attractive forces. Coulomb's forces can be attractive, maybe repulsive, but nuclear forces are always attractive only. These are saturated forces. And And the nuclear forces are independent of charges. This will depends upon the spin. Spin means what terminal direction, which direction it is orienting, which direction it is rotating. Based upon that, nuclear forces will depends. And the nuclear forces are exchange forces. They can exchange from one form to another form. And these are the non-central force. The central force means the force which will passes through the center of the atom, center of the bodies. That is called as a central force. But nuclear forces are not a central forces. Nuclear forces are non-central forces. Right. All of you do like and subscribe to the channel. So next time onwards, we will plan the classes in the channel. Okay. So that this, even if you, whenever you want, you can able to watch the classes. Okay. Whenever you want to watch, you can watch the classes from this channel only. Note karo. Yes, do note it. Note down. Spin depend means it depends upon the orientation. So that means if the whether this is, you might be heard about the Pauli's exclusive principle. Have you heard Pauli's exclusive principle? In chemistry, you might be studied these things. Spins. Two types of spins are there. So this upwards, downwards, we used to indicate now, isn't it? So based upon the spin, it will be the force values which depends. In which direction it is orienting, either clockwise or anti-clockwise. Okay, right. Next one. Mass energy equivalence. Mass energy equivalence. What is a mass energy equivalence means? So according to Newton, Einstein, according to what happened here? According to Einstein's, mass is nothing but energy. Mass Mass is another form of energy. Mass is one other form of energy. Mass is nothing but energy only. Okay, according to the Einstein, what he's saying here, mass is nothing but energy only. We can transform the mass into energy as well as energy into mass. So mass can be transferred. Mass can be converted mass can be converted into energy, and energy can be converted to energy can be converted into mass, vice versa. So, according to the Einstein, what he's saying here, mass is nothing but energy only. Energy we can convert into a mass, mass will be converted into the energy. If any body loses some mass, that means it is lost energy. If a body lost energy, that means the body loses the mass. Okay. So if a body loses the mass, that means it lost the energy. Mass is nothing but what? Energy simply. If energy of a body is increased by an amount, E, then the then then its mass then its mass increases by how much here? The increase of mass, which is equal to, that is E by C square. According to Einstein, if the energy of a body increased by an amount E, then its mass increases by how much? E by C square. And similarly, he has given that if M is the mass of the body, M is the mass of the body, disappears. Appears. Then, then the energy lost E equal to mc square. E equal to how much? Mc square. Okay. If m is the mass of the body, that means if a body loses the mass, means what? Tell me, it lost energy. If a body gains the mass, means its body will get the energy. Understood what I am saying? So this equation, which is called note down this thing. This equation, which is called as a mass energy equivalence. This is the relation given by the Einstein. The relation between the mass and energy. C is the velocity of light. C is the velocity of light. C value given as what? 3 into 10 power 8 meters per second. C is the velocity of light. Right. C is the velocity of light I given now. C 3 into 10 power 8 meters per second. Right? Next one. Mass defect. Mass defect. Have you heard this word, mass defect? Have you heard the word of mass defect? Mass defect. Hmm. Mass defect means, so just imagine you have taken some substance you have taken. So you have taken some original substance you have taken at this month. So you have taken certain substance you have taken. With this you made some object you have prepared. You prepared. If we calculate the before making the object, it has certain mass. And after designing the object will have certain mass. There is a difference between these two masses. There is a difference between these two masses. That is called as a mass defect. Okay. So this mass defect means, for example, mm, so you have taken some certain material. You have taken some material. You have taken some material. It has certain mass m. You have designed some neatly. You have designed one image. One, so here one doll or something you have created. So this mass is m dash. Initially, this is the mass of we have taken. Let us consider. So we have taken some clay. We have taken clay. So just yeah, Ganesh. So you have taken certain clay. You have taken this clay. You prepared some. So clay we have taken. You have prepared the Ganesh ka murti. So you have made this as a Ganesh murti. आपने बनाया. Okay. Now you tell me now here, this is the mass of the clay you have taken. This is the mass of the Ganesh. You tell me now here. So then after preparing this thing here, what happened to mass? You tell me the change in mass. So which mass is high? You tell me now here. Before making or after making? Which mass is high? Before making or after making? Before making mass is high, yes or no? That is given as m minus m dash. This is called as a mass defect. Okay, certain amount of mass. Just imagine when you have taken a clay during the preparation of this one idol. So what happens? You tell me. What happens now here? So you have taken certain clay while preparing here. Certain amount of clay will be lost, isn't it? Certain amount of clay will be for your hands, and some will be lost now. So that means whatever the lost of mass is there now, that is called as a mass defect. That is called as a mass defect. Is it fine, all of you? Hmm? Right. Now you can tell me now here. So mass defect means, write down, the amount of mass. The amount of mass. Mass lost means obviously energy will lost now. Mass is nothing but what? Tell me, energy. The amount of mass lost during the formation of nucleus. During the formation of nucleus is called mass defect. Is called mass defect. Okay, is called mass defect. The amount of mass lost during the formation of nucleus. The difference between the difference between the total mass of protons and neutrons and the true mass. Note down. True mass is called mass defect. Now, so this is mass defect, we can say delta M, which is given as, if we have the number of protons is Z and mass of the protons is what we can say Z into MP, mass of protons. Number of neutrons is N, mass of neutron is what? Each neutron is Mn, minus what we can say here, this is M dash, where this M dash is called as a mass of nucleus. And what is the Z is a, what is the Z is a atomic number. Atomic number is nothing but what? Tell me, number of protons. Z is what? Atomic number, that is nothing but what? Number of protons. And N is what? Number of neutrons. MP is what? Mass of proton. Mass of proton. And Mn is what? Mass of neutron. Mass of neutron. And this M dash is what? Mass of nucleus. M dash is a mass of nucleus. Then everybody completed. Right, fine. Okay, that's for the today's sessions, and we'll meet in the next class. We'll meet. Next class will continue the remaining topics. Will continue. Okay then. Okay then. See you. Bye bye.